The following three examples involve solving compound inequalities. What I want you to notice about number one is that you'll see there are two inequality symbols, and they're pointing in the same direction. If you go from left to right, this says less than, and this says less than or equal to. But notice the word less than. So less than, less than. So it should always look like this. So if this says less than, this should say less than. It should never be the opposite. Keep that in mind. So if this says less than and this says greater than, something's wrong in the way that this inequality is written. It should always be in that form. As you go from left to right, it should be the same direction. Less than, although this is less than or equal to. Okay, so in solving a compound inequality, notice that on the outsides, on the outer sides, those are constants. So that makes this an easy inequality to solve. That's the easy kind. And so all you see is in the middle is a variable expression. So the idea is to try to solve this inequality. The best way to solve this inequality is to try and get the variable in the middle by itself. All right, so if all you had was this linear inequality, this simple linear inequality, rather than this compound, you know what to do, right? To get x by itself, you're going to subtract 3 from both sides. But in this case, you're going to do it to all three parts. So notice subtract 3, subtract 3, subtract 3. And I'm lining my like terms. And so a -9 and a -3 is a -12 is less than 2x. This is 0 when I combine them. And that's less than or equal to 11. And a -3 is, what's that, an 8? Okay? And then to get the variable x by itself, so if all you had was this simple linear inequality, you know to solve for the variable x, to find the solutions to this simple inequality, you would have divided both sides by 2. Well, in this compound inequality, you do the same thing. Divide all parts by 2. And so you have -12 divided by 2 is -6. Is less than x, is less than or equal to 8 divided by 2 is 4. All right, so that is your solution. So the solution to the original inequality would be any real number, whether it's rational or irrational, that's between -6 and 4, including 4 because of the equal sign, but not including -6 because there's no equal sign. You're also going to be asked to write this in interval notation. So when writing something in interval notation, always go from left to right, from smallest to largest. So this is the smallest, -6, 4 is the largest. So since there's no equal sign on -6, we're going to put parentheses, -6, comma, and then 4, since there's an equal sign, since 4 is a solution, it's going to be a bracket. All right, so -6 has parentheses because -6 is not a solution. But 4 has a bracket because 4 is a solution. In terms of a graph, usually if you're going to do this by hand like this, you'll put 0, and then you know -6 is on the left, and you know 4 is on the right, and all you do there is just use parentheses and brackets. So you'll say parentheses, make it look like a parentheses, and then bracket. Now, probably at times, you may use open circle and closed circle. So let me remind you about that. So since -6 is not a solution, you're going to put an open circle, make it look like an open circle. And since 4 is a solution, you're going to put a closed circle. All right. And remember, you're graphing the solution, so you got to graph all the real numbers that are between -6 and 4. So make sure you shade in. It's got to be shaded in. Notice no arrows. It has to be shaded in, just like this. Okay, so don't just put parentheses and brackets. Remember, you're graphing the solution. So the solution is any real number between -6 and 4. All right. Now, you could have, just to let you know, since this is a compound inequality that looks like this, where you have a double inequality, you could change this to an AND statement. So we're going to not use the word OR here. So you can write as an AND statement. You'll get the same solution, except it's a little bit longer to deal with, an AND statement. And so you'll get, let me go ahead and rewrite this over. So you have -9 is less than 2x plus 3 is less than or equal to 11. So when I write this, I'm going to break it down as two statements with the word AND between them. Okay, that word AND is important. So you'll say negative 9 is less than 2x plus 3. So it's kind of like you're covering up the inequality part that's on the right side. Okay, and you're going to cover this part up, and you're saying 2x plus 3 is less than or equal to 11. All right, so what you're saying is that the solutions to this original inequality would be the solutions that are in here, and what they have in common. So that word "and" would mean the intersection. So when you do it this way, you're looking for the intersection. All right, and so now you're just going to solve each of those individual simple inequalities. So you went from a compound statement to two simple inequalities of the word "and," that means intersection. So I'm going to subtract 3 from both sides. So I get negative 9 and a negative 3 is a negative 12. It's less than 2x. And so you see this negative 12 right here? That's this negative 12 right here. See that? And then dividing both sides by 2, I get negative 6 is less than x. See that negative 6? That's negative 6 here. Just negative 6 here. But remember, many students prefer to write this in a way where the variable x is on the left-hand side. So remember how to read this. This reads negative 6 is less than x, meaning negative 6 is the smallest of any, is the smallest of the solutions to this, to this simple inequality right here. Although negative 6 is not a solution, it's a no equal sign, but the smallest solution is no more than negative 6, no less than negative 6. So what some students prefer to do is to rewrite this going the other way. So negative 6 is less than x means x is greater than negative 6. So that is what they prefer to write. So the solutions to this simple inequality right here, so the solutions to this simple inequality right here would be any real number that's greater than negative 6. We do the same thing here. Subtract 3 from both sides. I get 2x is less than or equal to 8. So notice this 8 is the same as this 8. And so divide both sides by 2, I get x to be less than or equal to 4. So what I found is that the solutions to this simple inequality would be any real number less than or equal to 4. But remember, I'm trying to find the solution to this compound inequality. So what we got to do now is look at those two intervals, those two inequalities right here. We're going to put this on the number line. So here's negative 6. So x is greater than negative 6 means this, parentheses going to the right. X is less than or equal to 4, so I'm going to graph that solution. So that interval. So here's 4, bracket, going to the left, less than or equal to. And so the solution to the original inequality, to this compound inequality, is the intersection of these two graphs. So the intersection of these two graphs. And so therefore you can see that the interval is going to be from negative 6 to 4. So negative 6 with parentheses, 4 with a bracket, because negative 6 has parentheses here, 4 has a bracket there. In terms of an inequality, if you're asked to write this back as an inequality, remember your solutions are between negative 6 and 4, right? And my variable is x. So you're going to say x is between negative 6 and 4, including 4, not including negative 6. The graph, then you're going to say this. Remember, this is not the graph of the solution right here. This right here represents your thought processes in terms of what this means when you graph this inequality and you graph this inequality and you look for the intersection. That's your thought process. So remember, that's not your solution. So your solution is this right here. You'll say negative 6, 4, parentheses, bracket, and then shade it in. Okay? All right, so that is number 1. So most students, though, when they see something like this where there's just constants on the other side, they'll just solve it to where they get x by itself in the middle. That's the easiest way to do that one. Let's look at number 2. All right, number 2, you have 3x minus 5 is less than or equal to 8x plus 1 is less than 3x plus 17. Okay, so in this case, you have variables in all parts. See that? In the previous problem, you did not have that. You had just a variable in the middle part. But here you have variables on both parts. Now this one's still easy because on the outsides, the variables are the same. So the variables are the same on the outside. If the variables are the same on the outside, see 3x, the variable expression, then you can do it just like this. Okay, so I'm going to go ahead and do it that way. So I'm going to go ahead and subtract 3x from all parts, just like this. And so when I combine like terms, 3x minus 3x is 0, so I'm left with negative 5. Is less than or equal to 8x minus 3x is 5x, plus 1 is less than the 3x's cancel out, so that's 0. You're left with 17. And now notice this right here looks just like number 1. See that? Just like number 1. And so I'm just going to get the variable by itself. So let's go ahead and do that. So subtract 1 from all parts. Negative 5 and a negative 1 is a negative 6. Is less than or equal to, this is 0. 5x is less than 17 and negative 1 is 16. And then finally get x by itself. You can divide both sides by 5. And so I get negative 6 fifths is less than or equal to 5 divided by 5 is 1. 1 times x is x. Is less than 16 fifths. Okay? And there's your solution. So your solution to the compound inequality right here would be any real number, rational or irrational, that's between negative 5 and 16 fifths. So if you want to rewrite this using mixed numbers, you can. So it'll be negative 1 and 1/5 is less than or equal to x is less than, and this is 3 and 1/5 as well. And so on the number line, you would say here's negative 1 and 1/5. Here is 3 and 1/5, right? This is the equal sign, so I'm going to put a bracket on negative 1 and 1/5. Here's 3 and 1/5, so I'm going to put a parentheses. There's no equal sign. I'll put a parentheses here, make it look like a parentheses, and then shade in all the real numbers that are between those two numbers. So there's an infinite number of solutions, to this inequality, to this compound inequality. All right, so any real number, so that would mean any rational number, any irrational number. The interval would be, so you'd say bracket. You just read it as you see it, bracket. I'm going to go ahead and leave it as a fraction, negative improper fraction. Negative 6 fifths, comma, and then 16 fifths with parentheses. All right, and so that is it. So that is number 2. Okay, so again, when the variables, if you have variables in all parts and the variables on the outside, the variable expression on the outside are the same, the variable expression 3x, it easily transforms to this. All right, now let's look at this. So look at number 3. So in number 3, we have this. We have x minus 10 is less than 4x minus 7 is less than or equal to 3x minus 4. So notice I have variables in all parts, right? X, 4x, 3x. The problem here is that the variable expressions on the outside are not the same. So you cannot, it's impossible to get it to look like this, where you can transform it to where you only have numbers on the outside, real numbers on the outside. So for example, if you subtract 3x on both sides, just to show you, if you subtract 3x from all parts, it's not going to work. Because look, you have x minus 3x is a negative 2x. Minus 10 is less than x minus 7 is less than or equal to, and this is 0, negative 4. So you still have variable here. You don't have just constants on the other side. All right, so that's not going to work. So doing it this way, it's not going to work. So what you want to do, I'll go ahead and rewrite this over now. So here's the problem. And listen carefully to this. So it's a little bit of work, but it's still doable. Okay, so what you're going to do is this. You're going to do it the same way. Watch. You remember this right here? Where we wrote this as an and statement? That's how you're going to do it. The only way you'll be able to do this is to write this as an and statement. So let's go ahead and do this. So you're going to cover this part up so you don't get confused. So here's your work. So you have x minus 10 is less than 4x minus 7, and you must put the word and put the word and. And at the same time, 4x minus 7 is less than or equal to 3x minus 4. And so all you do is just solve each of those simple inequalities, and then you go from there. So this part here that we're about to do, that's the easy part because you've done this before. So let's go ahead and solve for x in the first simple inequality. So I'm going to go ahead and subtract x from both sides. X minus x is 0, so 0 to negative 10 is a negative 10. It's less than 4x minus x is 3x minus 7. Then adding 7 to both sides, I get negative 10 and 7 is 3. Negative 3 is less than 3x. This is 0. Dividing both sides by 3, I get negative 1 is less than x. Now remember what this means. So negative 1 less than x means that all your solutions have to be, all the solutions to this simple inequality here, so that means all the solutions have to be greater than negative 1. That's what that means. So negative 1 is the smallest of any real number. That's the solution to this. Most students, though, prefer to write it this way, so x is greater than negative 1. So negative 1 is less than x means x is greater than negative 1. All right, let's do this one. So for this one, I'm going to subtract 3x from both sides. So 4x minus 3x is x, minus 7 is less than or equal to, and then that's 0 here, so you're left with negative 4. Adding 7 to both sides, I get x is less than or equal to negative 4 and 7 is 3. So the solutions to this simple inequality right here would be any real number that's less than or equal to 3. But you're trying to find a solution to this compound inequality, so that's where this and statement comes in. So you got to look at the graph of each of those two individually. So you're going to graph x is greater than negative 1. So here's negative 1, greater than parentheses going to the right. 3, make sure you put 3 on the right side. So 3 is here on the right side of negative 1. This is bracket going all the way to the left because less than, right? And then you're going to shade in what they have in common. And so your graph then, now this will be the graph of the compound inequality. So the solution to the compound inequality would be any real number that's between negative 1 and 3 with a bracket. All right, so that's the graph of this. Well, the solution, this right here is a solution to this compound inequality. All right, so I'm going to do this. So that's a solution to this. Okay, solution. So that's your solution written as a graph. In interval notation, that's pretty easy to do. You just read what you, that is your interval notation. Sorry, that's your interval notation. The graph is this. All right, here's your graph. So here's negative 1, here's 3, parentheses, bracket. That's your graph. Okay, make sure you shade in everything between, right? So that's your interval notation. So interval. You just read what you see, negative 1 to 3. Then the graph, you just go from negative 1 to 3, just like this, negative 1 to 3, parentheses, brackets. And as an inequality, meaning you want to make it look like this right here, right? So as an inequality, you just write what you see. So negative 1, that's parentheses, right? Is going to be less than x, is going to be less than or equal to because of the bracket, 3, and that's it. So there's your interval, there's your graph, and that's the inequality notation. So this right here, all of this would be ways to write the solution, of the original inequality. Okay, so those, the interval, the graph, the inequality, those are the solutions or the ways to indicate the solution to this compound inequality. All right, so that was 3 examples on how to solve compound inequalities where you have constants on both sides, or where you have variables in all parts, but the variable expressions on the outer sides are exactly the same. So that's the easy kind. It looks like this right here. But then we also talked about where we have variables in all parts, but the variable expressions on the outside are not the same. So you're going to have to write it as an and statement. Remember, and means intersection, right? end means intersection. So that's why we looked at the intersection of those two graphs. And then we came up with the interval notation. We came up with the graph and then the inequality. All right, so that will be the end of those three examples.